Welcome back to Service Ampacities for Apartments and Similar Dwellings. In this last video, we're going to look at two things. We're going to look at how to properly size our conduit fitting our service, and we're also going to look at the rules behind reducing our neutral. When it comes to conduit sizing, we need to know a few things. First, we need to know what size of conductors are going to be inside the conduit. We also need to know how many of those conductors are going to be there, as well as the type of insulation that's going to be on those conductors. Lastly, we need to know what kind of raceway we are going to be using. All of these different pieces of information will play a part in sizing the conduit properly. With our service, we've already determined that we're going to be using 750 kc mil conductors, and since it's a 120-240 volt single-phase service, we're going to require 3 conductors. If you're working with a 3-phase service, you would have to have 1 extra conductor in there. We know that the type of conduit coming into our service box is going to be rigid PVC, and we know that our insulation type on our conductors is RW90 600 volt non-jacketed. The first thing we want to do is start with our conductors. We have 3 750 mil conductors of RW90, and we take all this information over to Table 6A. Table 6A is based on the type of insulation that we have for our conductors. We're going to follow the left-hand column down until we find 750 kc mil. Then we also follow the top row until we find the number 3. Once we cross-reference those numbers, we now have how much space those conductors will take up inside the conduit. We will have a total fill value of 2,037.99 millimeters square. Our next step is to go check on table number 8. Table number 8 tells us how much of that conduit that we can fill. Remember that we want to have extra room in there, not only to make it easier for us to pull our conduits in and safely pull them out, but we also have to allow air for the heat to dissipate from the conductors. Table 8 says that if you have 3 or more conductors in the same conduit, you cannot fill that conduit past the 40% level. That means that 2,037 millimeters square that we found in Table 6A can only be 40% of the maximum fill of the entire conduit. Now that we have how much room the conductors are going to occupy, as well as what our fill percentage is, we can now go find our conduit size. Table 9G is based on a 40% fill and has our type of conduit on it. Therefore, we're going to find our rigid PVC on the top row, and we're going to follow that down until we find a value that exceeds our 2,037.99 millimeters square. Once we find that value, we can follow it over to the left-hand side to find out our trade size of conduit. In this case, we need to have a trade size 91 conduit for this service. There is a rule in the code that does say that we are allowed to have a smaller neutral than what our hot conductors are. Normally, we would base our neutral conductor on our hot conductor size, but if our service is over 200 amps, then we are allowed to reduce our neutral. The reason behind that is that most of the load will be shared between line 1 and line 2. So the neutral normally does not see as much ampacity as either one of the hot conductors. Rule 418.2b states that if our hot conductor has an ampacity of more than 200 amps, then we can derate the amount exceeding 200 amps by 70%. When we look at our maximum unbalanced load, we have an ampacity of 462.6 amps. According to Rule 418.2b, we take 100% of the first 200 amps. This leaves a value of 262.6 amps that we have not accounted for, and we will take 70% of that value towards our neutral ampacity. Once we add those two values together, we get a total ampacity of 383.82 amps, and this is now the minimum ampacity my neutral conductors must be. Table 2 states that now we can reduce our neutral to a 600 kc mil conductor instead of the 750 kc mil conductor that we had before. Let's take a look at what standard neutrals compared to reduced neutrals look like when it comes to conduit sizing. Now we have 2 750 kc mil hot conductors and 1 600 kc mil neutral conductor. Our steps are still the same. We're going to start with Table 6A, but now we need to get the size of both the 750 kc mil as well as the 600 kc mil conductors, and then we add those together. This will give us a total area of conduit that we're going to fill. Table 8 value is still going to be the same at 40%, and we're still going to use Table 9G. With our new fill value of 1,920 millimeters square, Table 9G tells us that we still are required to use a trade size 91 conduit. One of the reasons why we reduce our neutral is for cost savings, and while we did not save anything on our conduit size, we would still save money on purchasing a 600 kc mil conductor instead of a 750 kc mil. You've now reached the end of this module. We have looked at how to properly size our feeder conductors for each suite that we have, as well as looking at the feeder conductors for both the house panel and the parking lot panel for any loads that are not found within the suites. We then took all that information to see how it affects our total service size, and from our service conductor sizing, we were able to determine what our conduit was going to be to come into our building. Make sure you are reviewing all the information within this module and doing the practice questions online. When you're ready, you can continue on to the next module. If you have any questions, please make sure you reach out to me.